Welcome everyone, and thank you for joining this webinar about NextBillion's distance matrix API capabilities. My name is Sharad Kumar. I am the product manager for NextBillion. In today's session, we will focus on our distance matrix APIs and its capabilities. To set the agenda for this whole session, we will start off with a short intro about NextBillion, who we are, what we do, and our capabilities, and then move on to a short intro about distance matrix and what exactly it solves. Following up to that, we will get into the NextBillion advantage, the features which give us an edge over our competitors. We will then get into some use cases of the API and a short demo on the API and how we can visualize it. Finally, we will finish off with a case study about one of our clients and how using a customized matrix API, they were able to scale their business higher and the business benefits that they derived from it. So we are an end-to-end solution for your location requirements. We have the API ecosystem consisting of geocoding and reverse geocoding, distance matrix API, directions API, and navigation APIs. We also provide you with a set of applications to develop your own maps using our SDKs, using our map tiles. We also provide data enrichment utilizing the customer data and enriching it with points of interest, additional partner data, your telemetry, and adding certain kinds of restrictions and route avoidance capabilities. So what are the location-based challenges that businesses face today? Right? If we move on to daily usages like all the applications that we use, be it ride hailing, be it food deliveries, or just finding the route from A to B for traveling from one location to the other, we would have surely come across some of these issues, right? So mainly inaccurate ETAs, maybe some routing does not take into consideration if a particular area is one way, or similar issues with ride hailing, for example, incorrect pickup or drop off points. So once we extend this to businesses, right? So these inefficient API and map data, they combine to give a huge negative impact to businesses. You will have high API costs, which lead eventually to inaccurate pricing, cancellations, delayed deliveries, unsatisfactory customer experience. What it does to businesses is that it affects your bottom line. You are increasing your costs and effectively you are decreasing your revenue with the cancelled, delayed deliveries or cancellations, right? So when we use all of this data that all of our ecosystem and the data that we get from clients, we provide an end-to-end experience that is efficient, that is customizable, and that is specifically tailored to your use cases. So we have different vehicle profiles, access restrictions that we can add, some missing roads that we can add, and our algorithms also take into account driver behavior and the different speed profile in order to give you a very accurate routing information and accurate map information. One of these entities that help in driving all of this this ecosystem, right, is the distance matrix API. So what exactly is a distance matrix, right? It basically it solves for a set of origin and destinations and computes the distance and ETA, which is the expected times of arrival for each pair. So we can have scenarios like we have just one origin and many destinations, and we provide the distances and ETA for each pair, or many origins and many destinations. And similarly, we provide the distance and ETA for each pair. Now, there are a few key features that we would like to highlight here. NextBillion offers very large size matrices to the order of 5,000 origins and 5,000 destinations. Compare that to the market standard where Google and Mapbox to date only provide a size up to 25 origins and 25 destinations. Another key feature of our API is that we are cloud agnostic and can be deployed on premises. What this means is that you face little to no integration difficulties, and most of all, you solve your latency issues by deploying it on premise. So taken together, this leads to at least 2 to 3 times lower latency and 10 to 20 times higher throughput compared to our competitors, and up to 40% increased in ETA accuracies. We also provide flexible pricing, and we customize to your business model, giving you cost efficiencies on top of superior performances. So our APIs are customizable by using some advanced machine learning algorithm to process both proprietary and third-party use case specific data in conjunction with live traffic information. So by sharing your historical or operational data such as origin and destination, lat long pairs, travel time, speed profiles, or vehicle types, you get an API that is deeply customized to your use case, be it routing preferences, vehicle data, regional nuances, driver behavior, etc. We crunch it all to deliver accurate predictions every time, everywhere. So who exactly needs a distance matrix? Simply put, any businesses where vehicle movements are operational requirements, they have a need for distance matrix. Using our ecosystem, we solve for operational challenges like order batching, time-based routing, vehicle and time-based road restrictions. So what they mean, for example, if you have a truck fleet, there might be routes in which, for example, some vehicle are only allowed up to a certain heights, right? So our APIs will take that into consideration, provide you an alternate route. Similarly, there might be compliance requirements that, or vehicle weight requirements. There might be time-dependent routing in terms of you want your route to be started, your trip to be started at a particular time of the day. It could be you might also need vehicle-specific routing. So, for example, a pedestrian route is much different than a two-wheeler route, which is much different than a four-wheeler's route. We can also include e-scooters in this vehicle profile. So this is a demo that we have prepared for distance matrix. Currently, you can see on the screen that we have loaded a map of London. We have the controls to choose the origins and destinations. And basically what we are going to do is just put down some points, locations here in terms of origin. So we have currently selected origin. We can put out one here, let's say one here, and then choose the destinations. And we will see on the right side of the screen, you will see the distance matrix start popping up. So yeah. So you can see that from origin 1 to destination 1, we have time of 1581 seconds and around 13 kilometers from here to here. From O2, we have like around 2200 seconds, around 19 kilometers of distance from this place to this place. We can keep adding the destinations here. So you can see this keeps on updating this matrix, which is, and it provides the ETA and the distance for each of these node pairs. So you can have, 3 destinations, 2 origins, and then obviously we can extend it to as many as we like up to our maximum sizes. So we can also analyze the distance matrix request and response to via tools like Postman, in which you can see the request structure, what all parameters that we pass, and we can select the routing, the origins. I have currently selected 2 pairs of origins of destinations, and then the vehicle profile, currently 4-wheeler. We have given it a NextBillion API key, which is issued by us, and this is basically the response that we get. It's a readable JSON format, easily consumed by any application. So you will have the arrays of elements with each node pair having a duration and a distance value. This is the information that is being displayed in this particular matrix. So I'd like to get into some small use cases and discover how distance matrix API is useful in solving specific challenges. Right. So one of the major things that almost everyone, every company which is using any kind of routing or any kind of matching kind of algorithms between its let's say driver partners and pickups, etc. All of such companies, they absolutely need a distance matrix capability. So like I said earlier, any kind of solution, it starts off with a distance matrix. So let me just switch to my example here. So we can see, let's take an example of, let's say, a home improvement kind of application in which you order or you need some repair work done in your home, let's say for plumbing, for electricity, and you have a list of your partners that can, that have some specialties, so, some kind of restrictions applied to their capabilities. And based on those input data, you want to match these requests, which we will assume that these are on the all the red side, and we want to match the one with our service providers, which are on the green side. So let's say, for example, this guy O2, and then there is a destination D1, right? So this guy is probably a plumber. You have ordered, let's say, an electrical emergency. This electrician is at there are two electricians, O3 and O4. They are this far. We probably might assume that D2 is somebody which might have a plumbing issue. D3 might have a carpentry issue. D4 again might have a plumbing issue, and so forth and so on. These will be individual partners of the application of your company, which have specific restrictions, like I said. And how it begins is with the distance matrix calculation. So we have solved, for example, which is the most efficient, shortest route between O1 and D1. We are looking for O2 and D1, O3 and D1, which were our electrician issues. O4 to D1 is also an acceptable route. Let's see, so from O3 to D1, it is going to take 1,309 seconds for a distance of almost 19.1 kilometers. And then O4, pardon me. So O3 is going to take around 937 seconds for a 14-kilometer distance, and O4 to D1 is going to take around 1,309 seconds and for a distance of almost 19.1 kilometers. We can obviously see that this O3 is the closest electrician to this to the matching of this person's requirement, which is they have an electricity issue in their home. So we want to match this person, this requirement with this engineer or this repair person, who is the closest and the closest person to this. So once we have solved for this particular distance matrix for these set of origins and destinations, and I can keep adding destinations, I can keep adding origins, and so once we have solved for this, the next step in any kind of optimization planning is finding the most efficient route to take, and matching all of the relevant actors to the requests that are coming in from their customers. So we take into consideration all the restrictions that we have applied to them. So for example, electrician only goes to electric requirements. Taking another case, probably in a ride dispatch kind of situation, you want to avoid some highways, you want to avoid some tolls and other things like that. So Distance matrix, like I said, it forms the first step in calculating the most efficient route, and the rest of the functionalities, they are taken care of by the ecosystem of APIs that we currently have. For example, our route optimization engine, which would give you the perfect path to follow from point A to B, as you can see on the screen as of now. The directions API is also used in it to calculate, to draw the particular route, taking into account all the road restrictions, etc. So I would want to move ahead and discuss a case study of one of our customers, Grassdoor, with you. So Grassdoor is one of our largest customers, founded in 2018. It aims to be the Uber of cannabis delivery. They operate in Los Angeles and Southern California. So Grassdoor offers on-demand and scheduled deliveries. And one of their key promises is to provide same-day deliveries in under 45 minutes to cater to all the consumer needs. So when it comes to on-demand deliveries, accurate ETAs are very central to meeting customer expectations and maintaining their satisfaction, right? So, people might have some complex urban environments like apartment layouts with multiple entry and exit points. They are particularly challenging in the regards of doorstep deliveries, right? So since a delivery isn't complete till the package is exactly in the recipient's hand, simply arriving at the location doesn't really suffice, right? The delivery agent must navigate to the customer's doorstep within the stipulated ETA. And this basically costs precious time in a very competitive market where every minute is going to count. There are a lot of new competitors entering the market, so it became very critical for Grassdoor to deliver a differentiated customer experience without compromising on their unit economics. So in order to ward off these new entrants and keep on scaling their market, what Grassdoor needed was access to a distance matrix API that could predict accurate ETAs. It could handle large API call volumes at scale. It could run at high throughput and low latencies and still remain cost effective at scale. So we know that for last mile and on-demand deliveries, calculating accurate ETAs and optimized routes, it's paramount to achieving optimal operational efficiencies. And an accurate distance matrix API, it forms the foundation of any optimization engine. However, existing matrix APIs, they come with inherent limitations. For example, the matrix size of most APIs on the market is limited to 25 into 25 elements, which are the other competitors, which is entirely insufficient for optimization of large number of deliveries for large scale operations like Grassdoor wanted. So having identified the gaps there, these NextBillion's distance matrix API solve the following problems. So our APIs can support a matrix of 5,000 into 5,000 origins and destinations. Such a large matrix, it helped Grassdoor predict exact travel times while accommodating for driver pit stops and other variables. This in turn enables Grassdoor to consistently generate optimal routes and process accurate ETAs to maintain customer satisfaction. Next up, as a result of the optimization driven by our APIs, Grassdoor managed to lower delivery times and lower the number of miles driven by their driver partners, as well as expand their service coverage with the same fleet. This greatly boosted their profitability per order. We also offered flexible pricing model, and our costs, they compare favorably against alternatives such as Google Maps and Mapbox. So this competitive pricing, along with the flexibility to choose a payment model that works for their business, it further elevated Grassdoor's unit economics to the level that they required. A key differentiated factors that we have for Grassdoor is the fact that all of our APIs can be configured for on-premise, and they are also cloud agnostic deployments, right? So the ability to deploy our API within their Grassdoor's own cloud environment facilitated vastly lower operational latency and increased throughput, which empowered them to operate at scale with ease. So a collective outcome, to summarize, was that we provided a cost-effective distance matrix which catered to huge volumes. It was an on-prem deployment, and as a result, Grassdoor was able to reduce operational latency by almost 3 times, reduced operational costs to almost half of their existing spends, improved ETA accuracy by 35%, improved operational throughput by 20%, and eventually they were able to expand service coverage with their existing fleet. So that concludes our case study. Finally, let's summarize all that we have learned in this particular webinar. So we started off with an intro about the company, etc., and what exactly distance matrix is. So we learned that distance matrix are first and the most important steps in any optimized routing algorithm. We learned about NextBillion's competitive advantage, which are large matrix sizes, cloud agnostic and on-premise deployments, customizations, and flexible pricing. We also learned about distance matrix use cases, that they are used in almost every instance where a set of providers are to be matched with a set of requests, and the examples would include all instances of ride hailing, food or e-commerce deliveries, fleet management, among others. And finally, we ended with a case study of how NextBillion provided business benefits to an on-demand service provider, Grassdoor. So that concludes with our session. I hope we were able to offer you good insight into how our company operates, what business benefits we bring, and hopefully expanded your understanding of the distance matrix, the solution at its core. So this is thank you for tuning in, and have a nice day.